Scientists have long feared astronauts on a mission to Mars could go blind. Over the last decade, a number of astronauts, including NASA's Scott Kelly, have suffered from blurred vision on their return to Earth. Now researchers say they have finally discovered the cause of strange eye problems, and it could pave the way for much longer deep space missions. A new study has pinpointed volume changes in the clear fluid that surrounds the brain and spinal cord as the cause. This syndrome, known as visual impairment intracranial pressure or VIP, was reported in nearly two-thirds of astronauts after long-duration missions aboard the International Space Station. People initially didn't know what to make of it, and by 2010 there was growing concern as it became apparent that some of the astronauts had severe structural changes that were not fully reversible upon return to Earth, said study lead author Noam Alperin, Ph.D., professor of radiology and biomedical engineering at the University of Miami Miller School of Medicine in Miami. Experts previously thought that the source of the problem was a shift in the vascular fluid, including blood, towards the upper body that occurs in astronauts when they spend time in microgravity. However, recent experiments have concentrated on another possible source: cerebrospinal fluid. This is a clear fluid that cushions the brain and spinal cord while also circulating nutrients and removing waste materials. The fluid is designed to cope with changes in pressure that occur in everyday life, such as when a person rises from lying down to a standing position. However, the microgravity of space presents a new and unexpected challenge. On Earth, the CSF system is built to accommodate these pressure changes, but in space the system is confused by the lack of the posture-related pressure changes, said Dr. Alperin. NASA astronaut Scott Kelly suffered from vision problems during his 1999 mission and resorted to wearing reading glasses during his 2007 mission, reports Air and Space. He also reported vision problems during his 2010 to 2011, though this corrected itself within 3 months back on Earth. To find out more about what causes these vision problems, the researchers carried out MRI brain scans before and shortly after space flights for 7 long-duration missions for 7 long-duration mission ISS astronauts. Results were compared with those from non-short-duration mission astronauts who flew on the NASA's retired space shuttle. The team used advanced imaging algorithms to pinpoint any correlation between changes in fluid volumes and eye structure. They found that astronauts on long-duration missions had significantly increased flattening of their eyeballs and increased optic nerve swelling on their return to Earth, compared to those who flew on shorter missions. The long-duration astronauts also had greater increases in the amount of fluid around the optic nerves near the eyes. They also had more fluid in the cavities of the brain where the fluid is produced. The research provides, for the first time, quantitative evidence obtained from short and long-duration astronauts pointing to the primary and direct role of the CSF in the globe deformation seen in astronauts with visual impairment syndrome. Dr. Alperin said the study didn't find any changes in gray matter or white matter volume in either group of astronauts. The research is vital in preventing any long-term damage to astronauts' eyes, which could result in them becoming far-sighted. In future, even longer duration missions will need to be undertaken for humans to reach Mars, so it's vital that experts are able to understand what happens to the body when in microgravity for long periods of time. The new research is being presented today at the annual meeting of the Radiological Society of North America.